Good morning, Professor Lee and Professor Au. My name is Wing Yin, and today I'm going to present my undergraduate thesis about the topic Biomimetic Soft Calling Robots for GI tract inspection. To begin with, I will try to talk about some background information about the technique gastrointestinal inspection, as well as the concept of telemedicine and wireless technologies. GI tract inspection, or simply endoscopy, is a procedure for a doctor to see the inside lining of the digestive tract. This is usually performed using a flexible fiber optic tube with a tiny camera. Of course, there are advantages of current endoscopy procedure. For example, the inspection is often minimally invasive. Also, the morbidity and mortality are low. However, there may also some drawbacks and risks. Firstly, the human hand control may not be accurate enough, which may lead to bleeding or puncture of the GI tract. Secondly, as the endoscope is controlled by the doctor directly outside patient's body, its length cannot be too long. Moreover, the endoscope cannot enter lumen with too much folding and curvature, so most part of the small intestine cannot be seen. To overcome the above limitations, the concept of telemedicine could be applied. Telemedicine is a term coined in the 1970s, which refers to the use of computers, information and communication technologies, and electronics to improve medical procedures. Telemedicine covers a wide range of advantages. Firstly, it improves the access of healthcare services in rural and urban areas. Secondly, the cost of healthcare will be reduced. Last but not the least, telemedicine can reduce the travel time and related stresses for patients. They may now receive some medical services without the need to travel for a long distance or time. Nowadays, telemedicine is often related to the use of wireless technologies. Wireless network refers to the linkage between two or more devices using wireless communication. Wi-Fi, as one of the most commonly used wireless technologies, is based on the IEEE 802.11 standard. Apart from the use of wireless technologies, Internet transmission protocols are also essential for communication. A commonly used one would be the TCP/IP protocol. It describes how data can be broken down into packets, and how these packets can be addressed, transmitted, routed, and being retrieved at the receiver side. TCP/IP protocol adopts a client-server model in which one computer or one hardware device will act as a server, while other devices can communicate with each other with the help of the server. One advantage of TCP/IP protocol is that it ensures automatic recovery from failure of any device in the network. This reduces the chance of network disconnection error, which is an essential property for telemedicine technologies such as video-assisted surgery and remote endoscopy. The objective of this project will aim at the integration of ICTs with current GI tract inspection techniques to promote the mass screening and pre-screening of gastrointestinal diseases. A computer application will be built in which it can provide both video inspection from endoscope and the controllability of the soft biomimetic robot. Serial port and Wi-Fi connection technologies will each be used in two different inspection modes for this computer application. For this project, C# would be a major programming language used for the development. C# is object-oriented, with features like garbage collection, try-catch exception handling, as well as type-safe design. The most important reason for choosing C# is that it is component-oriented. Programmers will be natural and easy to use all the components and control from C# to build a well-looking graphical application. aforge.net is an open-source C# library for developers to build projects about camera, computer vision, and video processing, etc. In this project, it would be a major library used for accessing endoscope vision, as well as other related functions such as video frame capturing and video recording. Concerning the connection between the endoscope and the PC application, we can simply plug in the endoscope to computer's USB port for an USB direct mode. However, this will be difficult for the Wi-Fi connection. For most cameras, companies may release their own streaming web link. However, for the simple USB endoscope used in this project, there was no any release of links from the company or factory. Therefore, we have to make use of our own Raspberry Pi module. Raspberry Pi refers to a series of hardware modules that support Internet of Things development. It can recognize different cameras and output a video streaming link. This requires certain programming for Linux system with the help of an open source library, the Motion JPEG Streamer. For the soft robot controlling part, we can simply connect the Arduino board to the computer via USB port for a wired connection. For the Wi-Fi connection mode, Node MCU module will be used. It is an open source firmware and development kit that helps users to develop some Internet of Things projects. It can be viewed as a combination of a normal Arduino board and an ESP12E Wi-Fi module, allowing easier programming using Arduino syntax and Arduino IDE. Reason for using Node MCU is that it can integrate with an Arduino board with only slight change in the code. The Node MCU is programmed in a way that it can connect to the Arduino board via the TX-RX pin easily. After talking about the background, objective, and methodology of this project, maybe now should be the time to have some real demonstration of the computer application. This is to examine the multi-inspection ability of the application. It is now connected with 4 endoscopes, and each endoscope will point towards a character on the table. This is another type of multi-inspection, in which the 4 endoscopes are viewing one object in different directions. This is to examine the real operation with the soft biomimetics robot. Here, the robot and the endoscope camera inside are both connected to the computer via USB ports. User can control the soft robot manually and obtain the view of the endoscope. User may also record the video during inspection. After recording, user can make use of the application to view the recorded video, which is based on the Windows Media Player core library. For the Wi-Fi inspection mode, user will require to enter the IP address and the port number for accessing the video stream. The endoscope will again try to point towards some characters on the table, as we can see on the device screen. The last part of the real demonstration is the examination of the Wi-Fi control of the soft robot. As we can see, the controlling application, as well as the computer, have no any direct connection with the soft robot. Therefore, this application can successfully build up a wireless connection with the Node MCU module, which further control the robot by the user commands from the PC application. In the future, one major development of this project would be the addition of an automatic inspection mode. When the user turns on the auto mode, the program should control the movement of the soft robot spontaneously, which will require an integration with our visual servo. This also further increases the efficiency of GR check inspection and reduces the manpower for carrying out the procedure. The user interface will undergo continuous modification to provide a better user experience. Finally, some minor functions such as keyboard hotkey control and changing language, etc. may be added as if time is available. In conclusion, endoscopy is one of the most commonly used techniques nowadays for the detection of gastrointestinal diseases. However, our human hand control may not be the best. In order to improve current procedure, we may apply the concept of telemedicine. This project mainly focuses on the development of a computer application for both the inspection and control of the soft biomimetic calling robots. It supports both USB direct connection as well as wireless communication via local Wi-Fi network. With the use of this application, it is hoped to enhance the mass screening of GR checks and the pre-screening of GR checks diseases. The multi-inspection feature of this application also allows specialists to monitor multiple GR checks, which greatly reduces the time for doing checking. Here are the references for this presentation. And thank you for your listening.